listen.
Hello, everyone. This is Data Driven Chat, and today I'm very pleased to introduce Dan Becker, who is a co-founder and CEO at decision.ai. He is also an expert in machine learning, deep learning, and artificial intelligence, and does really cool work in this area. So, hello, Dan.
Thanks for having me.
Thanks a lot for finding the time. So let's just kick off with the first question. And I just to kind of, as an icebreaker, I wanted to ask you, how did you become interested in machine learning and artificial intelligence? What has driven you to this career?
Yeah, I think that just as a personality trait, I have always been really fearful of getting left behind or like only having outdated knowledge. And so I got into the field of AI about 20 years ago. And at first, my logic was, I just was interested in programming for reasons I could never put my finger on, but I played around with it and enjoyed it. And then I said, well, if you can imagine working on systems that are smart, which is AI, like intelligence seems like that should be smart, or systems that are less smart, it seemed inevitable to me at the time that the world was going to move towards systems that are AI driven or that are inherently smart or intelligent systems. And so I sort of forecasted or guessed that would be a hot area. And I sort of, in some ways I got that. It sounds like in retrospect I got that right, but there's a period where I got that wrong. My first programming job was one. This was in about 2000, where we were trying to use neural networks to help online retailers optimize things about their postings. And at the time, the state of the art for neural networks is not nearly as impressive as it is now. And then also, I was just out of college, and so whatever the state of the art was, we actually knew nothing about what we were doing. And so it was a total, complete failure. And after working on that for like 6 to 9 months, I decided that AI and machine learning would never catch on. They were going to be complete failures, and that anyone who believed they could catch on just thought that because they didn't have any experience with it. And so there's a long period of time. I got a PhD in econometrics during this period of time. But a long period of time when I said the right way to deal with data is to make graphs and look at them and to use very simple, comparatively simple techniques. And I felt that way until about 2009 when I did a Kaggle competition using the sorts of techniques that people from economics backgrounds typically use, sort of simple linear regression or GLM style models. And I was trying to compete in a competition. I expected to do well. And I think originally there were about 1,000 people when I entered, and I was in like 990th place. Mm-hmm. And so that made me wonder, what is everyone else doing well that I'm doing poorly? And so that was when I started moving back to machine learning type approaches. And I'm naturally a little bit competitive. And so I just spent every waking hour when I wasn't at work competing in this competition and learning about ML again. And I did well in that competition and got a job doing analytics consulting, which let me see a lot of different applications. And I sort of bounced around since then. One of the things that I saw a lot then, which, so at that point I was doing machine learning. One of the things that I saw a lot then, which has really informed how I think about machine learning today, is that if you talk to someone with a problem to solve, let's say someone in a line of business, and they don't have experience with machine learning, there was this disconnect where they'd say, hey, my job is I'm in charge of determining which of our sales reps calls which of our customers, and I need you to tell me how to do that. And as someone who knew about machine learning, I would say, well, we can't really tell you what to do. All we can do is make predictions of something that's very specific and that is something that exists in the data. And there's this disconnect that I didn't know how to solve. And I know that you think a lot in terms of decision support, and that was the part that I was missing for a long time. But that's really where I've migrated my focus in the last year, is to say, how do we do that last mile from machine learning to actually making good decisions? But I think that my view on AI and machine learning has really been colored by those few years that I spent consulting and seeing a lot of applications, but seeing them through the eyes of someone who wasn't a machine learning researcher.
Yeah, I think this link that you mentioned, how do you translate the problem that businesses have into a machine learning problem? How do you connect these two populations? The people who know a lot about programming and the people who have a problem. That's also a very important connection. And I think we often lose sight in this. We're basically lost in translation sometimes when we talk to each other. I mean, the people from businesses and the people who code. So if you had to pick one most important thing that you have achieved during your careers, so what are you most proud of?
Yeah, I hope to have a new answer a couple of years from now, because I just started Decision.ai 2 or 3 months ago, and it's something that I'm a big believer in. But immediately before that, I worked for Kaggle, which has online free courses. When I joined Kaggle a few years ago, they did not. And so we now have free courses that are very, 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 very short, very, very applied, very, very directed towards trying to help people build independent projects so that they can have a cool portfolio and learn the bare minimum they need to do interesting projects and to sort of learn more on their own. So we built that program that has about 30 or 35,000 people a month who are taking our online courses. And so to go from 0 a month to 35,000 is, and to have it be a very unique approach to learning data science, which is not the right approach for many people, but is the right approach for many people. I'm really proud that we to have brought that into existence.
So can I just ask you a little bit more detail about these programs? So because students will be listening to this podcast. So do you need any prior training in order to take these courses, or are they catered for relatively kind of starter level? So what level should people?
Yes, so there are about 12. There are about 12 courses right now. The first one is Intro to Python, so that's truly something targeted towards people who are pretty new to the field. There's another that's Intro to Data Visualization, which is also if you finish the Intro to Python, you don't need anything else. Or there's Intro to Machine Learning. If you finish Intro to Python, or if you know little Python, you don't need anything else. But then we also have so 2 of the most advanced courses to see sort of the other end of that spectrum. One is called Machine Learning Explainability, which is to say, I've got a black box machine learning model. What do I do to understand what that model is learning to make it not a black box? That's a pretty advanced topic, and so that's a course that I've had people who I think of as quite advanced data scientists say they got a lot from. There's another one that was getting put together right as I left, which is I tend to think of it as a reinforcement learning course, but I think it's called something like AI for Games. And you teach a model that doesn't know anything about the rules of a game like checkers or Foursquare or something like that, to just play it over and over and over against itself and become a program that works well in a dynamic environment, which is useful because the world is filled with dynamic environments. And so I think that now it's fair to say that we cover a pretty wide range of the spectrum in terms of skill levels people come in with.
Awesome. So if you guys are listening kind of on the other side and you want to learn machine learning, so you should definitely pay attention to Kaggle courses. That sounds like fun. So tell me, what are you currently working on? What keeps you awake at night?
Yeah. I think, so it's March 2020, almost April 2020. The things that keep me awake at night today are different than they were a month or two ago.
Yeah, I appreciate that. Yeah, we will come to COVID-19 in the moment, but yeah.
Yeah, we started Decision AI with the intention of saying everyone is building these machine learning models, and they build them in almost an isolated environment. And I know so many people. Maybe if you exclude the people who work at Google, Amazon, and Facebook, the majority of people who I know who have built AI models have been hired by a company that knows they want to do that stuff, but doesn't know exactly where it's going to fit in. And so they have tolerated a data scientist or an AI practitioner building models without guaranteeing results. And then the data scientist builds the model, and someone goes, well, we're not sure how we would use it. And so many of these models never get out of a notebook, and they never get deployed, they never get used. And part of that is that it's actually really hard to figure out exactly the problem you alluded to earlier. How do I reconnect the model to the problem? And so when we started the company in January, we had an approach where we say someone can build almost like the way you would diagram a flow chart on a whiteboard. Someone can diagram all the different parts of their business process. Some of these are things you don't even have data about, but maybe you have some domain knowledge and we'll let you encode that. Some of it might be somewhere where you have data. And so you build a machine learning model to basically capture that little part of your environment. But we've got a way for you to stitch these all together and then say, whatever decision I'm trying to make, I can use this really quite rich simulation environment where we've put all these pieces together and try the different decisions or experiment with the different decisions and then deploy the decision or decision function that's optimal in our simulation environment. So that's where we started. And then 2 or 3 weeks ago, in March, we had a couple of companies that we were having early, we were thinking of as like pilot projects. Mm-hmm. We were really focused on supply chain management, and all of them basically came to a point where they said, we could build models, but the models are based on historical data, and data describing or capturing the patterns in how things worked 2 months ago is not relevant today, and it's probably not going to be relevant anytime in the next 6 or 9 months. And so we've switched. Yeah, and so I guess there's what am I working on, but then also what keeps me up at night. The thing that keeps me up at night at the moment is how do you make analytics useful or help people really make effective decisions in a world when the data is from a different period of history than we're in right now. And a lot of that is we've got the product we're building right now, we've said we're not even going to worry about your historical data. Later on, we'll add in that functionality, but we're about to release in the next couple of days a prototype or something that anyone can use, anyone that will be able to use for free. But everything is just you specify how you think the different parts of your process or your business works. In some cases, you don't know, and you say, I've got a statistical distribution. I think it's somewhere between 5% and 25% of people will take some action. And we've got a nice tool for you to simulate how different decisions will play out in that flow you've built, and then for you to inspect and understand the outcomes. But it's, for data scientists, a few months ago we struggled with relevance because we weren't good at translating our models to decisions or solutions. And now we have trouble with relevance even more because all we work with is data, and data was collected in the past rather than the present.
Exactly. So yeah, I think this kind of simulated environments and digital twins. Like at Turing, we do a lot of digital twins projects where we basically build digital environments and then we simulate them. Yeah, I think it's really important work, and yeah, one of the, for example, projects that I do is also about kind of trying to, not trying to reconstruct from historical data what customers wanted yesterday, but essentially the model is trying to guess what features of the product that they're going to want tomorrow, right?
Yeah.
And you kind of try to make suggestions and write a model that would actually tell decision makers in the company, what, how to basically what to produce next, right? What should I produce next?
So sometime after this, I'd love to, if you send me a link, I'd love to look at how you did that.
Yeah. So this is just theoretical project, but I'm happy to share with you. Obviously, I think, but it's really fascinating. So, So. A lot of people who are listening to my podcasts, they aspire to career in data science, machine learning, and AI. So can you give some tips to people who want to get into the field? So what do you think is the most important thing to remember if they want to get into the field?
So I've pondered this question a lot. And the thing that I have eventually decided is that if you imagine working backwards, so I want 5 years from now to be a great data scientist. So to do that, you need a lot of experience and a lot of just time. The number one way to have a lot of time that you've dedicated to being a data scientist is to get a job doing data science. Mm-hmm. Because then, if you were going to do it on nights and weekends, and then you could add in, well, actually, I do this as my job. So now you've got an extra 40 hours a week. So your trajectory just shoots up once you get a job in the field, and you've got mentors sitting next to you. And so now the question is, well, how do I get that first job that's doing data science? My view on that is that you really, and I've hired dozens of data scientists over the course of time, you really need projects that someone looks at that says that is an interesting project. You could be just great at understanding the matrix algebra of, involved in how you do backpropagation in a large network. That's not going to get anyone's attention. It's hard to pick that out of a resume, especially when resumes are piles of them right now. The thing that really gets someone's attention is to go to a web page, either a GitHub repository or a blog post, and to say, wow, the way that someone solved that problem is just really interesting. And so how do you do that? Some of it is just pick a topic that you find interesting. It doesn't need to be business related. It could be, if you really like movies, and you maybe are interested on a data science side from doing natural language processing, go out and see if you can somehow get a bunch of movie scripts and do something that's interesting. Something I saw somewhere was looking at, for different types of movies, doing sentiment analysis of are people at a high or a low, and tracing that out over the course of the movie. And then you can say, well, what movies are similar to each other in that way? I think that's an interesting question, especially if you're trying to make something interesting. It's really important that it's visual. Again, as someone who's done hiring, I know that if we're getting hundreds of resumes, which is not uncommon, it's pretty rare that I'm going to read enough into someone's blog post that it's going to pull me in. But if I see a graph at the top or a quick quote or just something that grabs me, I might actually read quite a bit. But it needs to be something visual, a graph, or something like that that really draws me in. In the same note, I think it's really important that people think of their portfolio as living on GitHub. There's a document in each repository called README or readme.md. It's a markdown file. And to have a really nice visual README, maybe it'd be nice if we lived in a world where people dug deep into your work and it wasn't important. But that is the way that no one's going to dig into code for something they don't understand. And so just presenting work that someone finds interesting at a human level as opposed to at a purely mathematical level, I think is really the key to getting your first job, and then you can take off from there.
I really like your suggestions about looking into movies, because so this is where I work mostly, kind of on motion pictures and NLP and emotional arcs. All I can say, like, normally my papers are quite technical and no one reads them, but I wrote a paper on emotional arcs in movies and predicting revenue, and I think 18,000 people read the paper. So I think that's like the highest read paper I have. So definitely movies is a good topic.
Yeah.
To grab somebody's attention. You kind of already touched on this, and as a consultant, you talk to a lot of businesses. So why do you think AI is particularly important for business now? How did it change the decision support systems in the last few years?
Yeah, I think of AI as being at a funny point, which is there are some tech companies that have been wildly successful deploying AI. And, there are a lot of companies that have not. And I've primarily been at tech companies for a long time. When I started my current company, Decision AI, we talked to, logistics companies and people we wanted to understand, are they a potential customer? And a lot of them said, we keep our data on paper. And so I think that's changing, and there are more and more companies that are becoming more digital. But we have a challenge of becoming important for business. I think most businesses have, in some sense, like, tolerated data scientists who have not yet paid off, because they know that there are some people who've been wildly successful and they want to get there. But I don't think it's changed decision support systems outside of some successful tech companies. I don't think it's changed them that much yet. Though I do think that the success of some companies proves that it can be done. And I guess the nice thing about it, like most things in software, is that it's really scalable. So that if you're Walmart and you make an improvement at one store, and it takes some effort to do that, to replicate that across stores is going to be a huge effort. And yet, if you had an AI algorithm that improved how you do stocking or improved something about your business, it's actually probably pretty easy to scale that up. So we have a lot of potential, but I don't think I think we're still figuring out how to deliver on that.
Don't you think that a lot of businesses, I just kind of want to pick a little bit what you said and kind of go a little bit in depth. Don't you feel that sometimes companies just say, we just want to do AI because they kind of want to jump on this train of doing AI, and they don't often think why they want to do it. Maybe simple automation that is not necessarily artificial intelligence is needed. Like, I certainly had quite a few conversations where, like you said, a simple visualization tool would solve the problem, or so it's not always that you need AI, right?
I think the world is still figuring out where AI is going to be useful. And in some ways so the problem that they face right now is that they don't have an AI team. And in many cases, that means they're not good at scoping AI problems, and they're probably not even that good at figuring out what data scientists or AI practitioners are good and who's not. And so I think in many cases, they're saying, well, we're going to build this capability because we know there's a chance that in 10 years, if you don't have this, you're not going to be able to compete with someone who does. So I don't think they're wrong to be sort of experimenting and accepting and investing at this point in things that aren't paying off. But right now it's hard to figure. Everyone is trying to figure out what pays off. And I totally agree with you.
So I also want to kind of to ask you about clearly like I said, a lot of people who'll be listening to this, they want to get a career in data science. So how important is the ability to code? And let me just maybe make the question a little bit more complex, because some of my students are, for example, executive students, and they work at the leadership level, and they are also quite worried right now that they need to have an understanding at the technical level of what's going on. So how do you think, how important is this ability, and where do you start? Like if you want to start learning, should you start learning Python, R? Should you take courses, or should you just take a practical problem and learn it by doing?
Yeah. So for, the easy part of that question to me is Python versus R.
Mm-hmm.
I think that languages, so this is a little bit different than purely human languages, because you do use languages to communicate with computers as well. Mm-hmm. But most projects are collaborative projects. And mm-hmm. if you look at the growth of Python versus R, mm-hmm. R is becoming a really narrow and niche language. Mm-hmm. And so it's sort of like if you were about to teach someone their first language, and you could say, I could either teach them Mandarin or English or Esperanto. You'd say, I should teach them Mandarin or English, because I want someone, it's useful to know a language that lots of other people know. And it's not that useful to know a language that not that many other people know. And in data science and practice, we need to collaborate. So I think that I think that's probably the easy part of your question.
So Python is your recommendation is Python.
I think Python. And when I started at Kaggle, I think maybe 30%. This is only 3 or 4 over the course of 3 or 4 years. I think 30% of notebooks written on that website were in R, and I think now it's under 10%. Mm-hmm. And it's just So Python is the language that
the dominant language. Yeah. Mm-hmm.
The dominant language, and so that's the one to learn. And then the question is how to learn it. People have different learning styles. I think that most people will find it most engaging to learn in a project where they have autonomy. Again, if you like movies, then doing something about movies is the way to go. You need to learn a certain amount before you could even conceptualize what could I do with movies and how would I even make progress. But I think that most people will find it more engaging to work on a project that's on a topic that's interesting to them. For many people, it's sports. Could be weather. One of the things everyone I know right now is doing all sorts of analytics about COVID-19. For someone who's spending all their time on Twitter or news saying, oh my, I can't figure out what's happening, there's a lot of public data, and this is a way to learn, focus on the thing that's already consuming all your mental energy, and also build data programming skills and data science skills. So I think for most people, projects is a really good way to do it, to learn, but you need to learn enough that you feel you can at least get started on a project. And then I guess the other part of the question, I think I've answered them backwards, is who needs to learn to code? I think that if you're going to be doing work in practice, you need to be able to code better than most people think. Mm-hmm. I, again, see a lot of people getting into the field and they can put something together in a notebook, but it's not maintainable. It's not something that someone else could build off of because of the way that they wrote their code. And the more people you collaborate with, and the more important it is that your code be well structured and be something that is actually nice code. And so I think that many people who are going to write any code underestimate the value of being reasonably good at coding, and knowing how to use Git and GitHub is really critically important. For executives, I think there's some value in knowing a little bit so that you have a little bit more intuition for like what's hard, what's easy, what can be done, what can't be done. There's a comment that I heard Owen Zhang used to make. He was the #1 top competitor on Kaggle for a while. And he said that there's probably a future when there are no data scientists. And he said this to a room of aspiring data scientists, and everyone went, oh my God. And he said, a lot of the things that you think of as data science are going to get automated away, and we're not going to need someone to do that, to do some like the details of model building. But then he said, the data scientists of today are the executives of the future, because it's just analytical thinking and thinking critically. Does the thing that I see here make sense?
Mm-hmm.
And so in that example, when you say, well, we've done an analysis and everyone is their own customer type, for someone to say, well, that probably means that if we had 100 people, you'd have 100 customer types. And so now you're not segmenting at all. Like that's something that is just an analytical person should be able to figure that out. And I think we are going to see some blending of like, it's really important to be analytical and savvy as an executive. And some of that is maybe aside from being able to implement things.
So we cannot obviously avoid talking about COVID. There are a lot of initiatives. I'm sure there are a lot of initiatives in the US. There are a lot of initiatives in the UK. Royal Society just had released a call. The governmental funding agency UKRI released a call on COVID. So, do you think AI can really help to solve the current crisis, or at least help to solve the current crisis? And if so, in what way? Can you see any particular application where it's going to be particularly useful?
Yeah, so my first answer is this is an area where I'm highly inexpert.
Mm-hmm.
I do know that there are companies that are using AI to help with creating new pharmaceuticals or new drugs. Maybe it'll be useful there. I wouldn't know. Maybe there's something about we can quickly detect based on some sorts of patterns whether there's a certain geographic area that should be put on a higher level of quarantine. It wouldn't surprise me if something's possible,
mm-hmm.
but I don't think I have much insight into what it is.
All right. So then like kind of drop in the COVID subject. In general, where do you think the field of AI and data science is going in the next 5 years? What important problems are out there to solve?
I think of there being two types of AI that are happening. So one is primarily happening in deep learning and computer vision and voice recognition and such. And that is the creation of new capabilities or new products. One that I don't know if it's going to be the next 5 years, but one that I'm really excited about is robotics. Mm-hmm. Robotics is a really, really hard problem. And as a result, AI has done a lot for us in areas that are there's no physical component. Right. You see like dematerialization, where things that used to get delivered to your house now get streamed to the internet. So I suspect that there's a lot of low-hanging fruit where once you can have robots do certain manufacturing processes better, so one area that I'm excited about is robotics, and that's all going back to what are the ways where we take capabilities that don't exist today and we create those capabilities. Now, the other side, which is not always, but in most cases working with tabular data, is saying, well, what are processes that are happening today where we can improve them a little bit? So an example that I think is like really exciting is if you imagine global logistics. So you ship things around on planes and ships and trains. If you could help them figure out how to arrange those to make more efficient connections and to get everything so that everything is packed full and you don't have freight trains that are if you don't have freight trucks that are driving around half full, you could decrease carbon emissions quite meaningfully just by making processes that exist today more efficient. And I'm a big believer that machine learning has focused on models that are so narrow that we can't address these larger problems, these more holistic problems particularly well. I started a company because I think, excuse me, allowing models or using models to capture bigger parts of the problem and help us make better decisions is the future. And so that's my bet on where we're going to go on the making the world more efficient for processes that exist. Is I think models that just capture more of reality.
Right, and I think another important problem that you already mentioned is the fact that all our models are, in one way or the other, are based on historical data, right? Which adds complexity to kind of making them more relevant for the future. And so I think that's definitely all these issues are very, very important.
Yeah.
So this is a trick question, but I can't not ask you about kind of ethics and responsibilities. So there is a lot of, I feel that right now we have more people kind of wanting to do governance than wanting to do coding, right? And so we have a lot of people who do governance of AI or do research in governance of AI and ethics of AI. So when you are actually constructing practical tools, how much do you think about ethics and responsibility and debiasing these algorithms that we are writing? How important is it as a consideration to you when you're building something?
So, first of all, I think this is such a hard problem.
Mm-hmm. I agree.
Yeah, and then you run into all sorts of considerations, like if you imagine 4 ethical people building tools and 1 ethical person building tools, then you end up with an unethical version of the tool out there. And if it's a surveillance tool, then you sort of end up with almost like a race to the bottom of whoever is least ethical has some advantage. And so I think governance is. I do think that I'm glad there are people thinking about the governance of AI, and I think there are probably a lot more in Europe than there are in the US where I am.
Right.
So I think about it some. In many cases, I've always felt that and a lot of this is because I've historically worked on tools that are used by data scientists rather than used by the line of business, at least historically. And so as a result, I've always felt like I have so little visibility into how the tools that I'm building are going to get used. I can't tell what the application is going to be that the data scientist uses it for. And so I think a lot of, I wish that I could say that it's something that I've done a lot about. And at the same time, it's something that I see things in the news or I see things in our field and think about that a lot. But then when I say, what can I do? I've always felt unempowered to do much about it. And then I even think people downstream of me who are closer to knowing how their work is getting used, I think that they're going to struggle to have an impact unless there's some really smart people thinking about the governance side, and especially with the field changing so quickly, the governance side is a really hard problem.
Yeah, it is, and you can think of purely, benign type of projects that might generate ethical issues. Like, for example, you could work on, let's just say, a food bank mapping model, right? That would tell people where to go to get food. Instead of kind of encouraging people to try to look for jobs, you are creating all sorts of dependencies. So, So I guess you could actually have all the put really good will into a project and yet create an ethical problem, right? So it's very, that's a tricky.
Yeah.
Tricky thing. Okay, so here's a traditional question that I ask at the end, if you had to recommend just one book and just one film, what would they be? And you can only choose one of each.
Okay. The book when I was trying to decide between a technical book and a non-technical book. I'm going to go to the technical book given your audience. Mm-hmm. There's a book and it's available as a book, but also available for free online. Bayesian Methods for Hackers is a really, really good book. And it's good both as teaching you methods you can implement, but I think it's short, it's very accessible, but it's also good for just being good at analytical thinking. So that would be my book recommendation. I'm not a movie buff. So a movie that I struggled to think of one. A movie that I remember enjoying, that I don't remember many details of it, but I remember thinking it was a great movie, was Memento. So someone wants an hour and a half of an interesting movie, that's my...
Yeah, that's one of my favorite movies, Memento. Yeah, I think it's awesome. I think it's all about kind of deconstructing the past from kind of the logic, right, of what is happening now. So
yeah.
That's an amazing movie. Well, thank you so much, Dan. Thank you for finding the time to talk to me. And this was an absolutely amazing conversation. Thank you so much.
Thanks for having me. And it was great chatting.
Thank you.
Bye.